right, our last section for chapter 9 is solving right triangles. And what we're going to do is we're going to start with something that we've done before. So they ask us to determine which of the two acute angles has a sine of 4/10. So again, remember sine is the opposite over the hypotenuse. So if I take Q here, there's the opposite, and the hypotenuse is always, again, opposite the right angle, so we know that one's 15 degrees. So if I look at sine of Q, that's telling us we have 3 times the square root of 21 over 15. Now I can take the 3 and the 15, since they're numbers, I can reduce those. So if I do that, I'll get the square root of 21 over 5. And if I plug that into my calculator, I'll get 0.9165. Well, that one's not equal to 0.4, so I'm sure it's got to be sine r. So sine of r, again, let's look at that angle there. So that would make 6 be our opposite, and our hypotenuse is still 15. So we'll have 6 over 15. It's a fraction I can reduce since 3 goes into both of them. So I know I can reduce that to 2/5. And if I take that, I would find out that it is 0.4. So what it's saying here is if the angle measure is known, then the sine of the angle measure is going to equal 0.4. So now, since I know what I'm doing, if you plugged in 23.6, it'll give you 0.4003 something. All right, so 23.6 would be the angle measure, and that's what we're going to talk about for the rest of this, is how to find those angle measures. So the inverse trigonometric ratio says let A be an acute angle, and so they're only taking one of these. All right, B should be an acute angle too, and they're saying that the inverse tangent, if tangent A equals x, then tangent to the -1 of x is equal to the measure angle A. Tangent to the -1 of x is read as the inverse tangent. All right, and they're kind of showing you it would again be BC over AC, so it's the opposite still over the adjacent. So that stuff doesn't change, people. All right, same with inverse sine. If sine of A is equal to y, then sine to the -1, or the inverse sine of y, is equal to the measure angle A, and same with the inverse of cosine. If cosine of A is equal to z, then cosine to the -1 of z is equal to the measure angle A, which again would be cosine to the -1. Again, AC, which is our adjacent, over our hypotenuse. All right, so they're just kind of telling you all of that. So let's go ahead and I'll erase all of that. And let's look at our next example. So this one, they're just trying to get you to learn how to use the calculator. And so I'll probably have to show you that tomorrow to make sure. All right. So let A, B, and C, angle A, angle B, and angle C be acute angles. Use a calculator to approximate the measures of all 3 angles to the nearest 1/10 of a degree. So we have that the tangent of A is equal to 3.29. So we know that the inverse, so the measure of angle A is equal to the inverse tangent of 3.29, and that will approximately equal 73.1 degrees. So again, remember to put your calculator in degrees. I notice every single time I start with Desmos, it goes right back to radians. So put it in degrees. Make sure you put it in degrees. If I haven't said it enough times, make sure you put it in degrees. All right, so we're going to do the same thing here for the measure of angle B. It's going to be the inverse sine of 55 thousandths, or 0.55. And if you do that one, you'll get 33.4 degrees. And then the last one is the cosine of C is equal to 0.87. So we would say that the measure of angle C is equal to the inverse cosine of 0.87, or 87 thousandths. And that one will equal 29.5 degrees. Okay. So now the last couple here, to solve a right triangle. So when it tells you to solve a right triangle, you have to find all the unknown sides and angle measures. You can solve a right triangle when you know either of the following. The first one, if you know two side lengths, and the second would be one side length and the measure of one of the acute angles. All right? So I'm going to give you an example of each one of those. And I did notice that in the textbook, it does ask you, well, on the Big Ideas platform, it does ask you for everything. So make sure you solve for everything. So example 1, solve the right triangle and round decimal answers to the nearest tenth. Okay. If you look at this one here, what do you know? On this one here, you have 25 and you have 24. Well, that one tells you have two sides. So let's go ahead and I'll just give you some steps on this one. Step 1, okay, use the Pythagorean Theorem. To find the missing side length. All right, now I know the Pythagorean Theorem, we're always saying a squared plus b squared equals c squared. But again, it's time to start recognizing that you're going to say, well, this one here would be side little c, right? This one here would be side little a, and this one here would be side little b. So that one's not going to work that way, ladies and gentlemen. So get used to saying the two sides, the squares of the legs equals the sum of the squares of the legs equals the square of the hypotenuse. So what we're saying here then is we have our two sides, our two legs are c squared plus 24 squared, and that is going to equal 25 squared. Okay, now question is, how many of you recognize that it was a perfect square, not a perfect square trinomial, but like a 3, 4, 5 triangle, one of those special right triangles that we talked about earlier. All right, a Pythagorean triple, right? Well, this one here is, but if you didn't recognize it, you would still solve for c squared is equal to 24 squared, which is 576. And that equals 25 squared, which is 625. So if I subtract 576 from 625, I'll get that c squared is equal to 49. And if I take the square root, remember to get rid of a square, I take the square root. If I take the square root of 49, I will get 7. And notice I didn't put plus or minus in front because, again, we're talking length on this one here. So that is one of our answers. So our answer would be C is equal to 7. Okay? Now, step 2, use the inverse trig function. To find one of the angles. Okay, now, and I'm going to show you this tomorrow after I have you watch the video. You can use sine, cosine, or tangent here. All right, we know now that, well, here, let's go ahead and make it be kind of the same color. We know now that c is equal to 7. All right, so you can still use sine, cosine, or tangent, the inverse of them. All right, so one of the things I always suggest is use the ones you know in case you made a mistake. All right, so on this one here, I would say that the measure of angle A, again, I chose A, I could have chosen C, but I chose A. And again, the ones I know, well, let's see, I knew the opposite, which is 24, and I know the hypotenuse, which is 25. So which one is the opposite over the hypotenuse? That's going to be sine. So we're going to take the inverse sine, and you can plug it in your calculator exactly like this. So the opposite over the hypotenuse. And when I do that, they said round it to the nearest tenth. So you should get 73.7 degrees. And then finally, the last one here, step 3. And that works with this one. It won't work with the other one because we only need to find one of the angles, so we know the two. So then we would use sine, cosine, or tangent to find the other two sides. So on this one here, because A and C are complementary, remember, complementary means that they add up to 90 degrees. So then we can say that the measure angle C is equal to 90 degrees minus the measure angle A, which in this case was 73.7 degrees. And if we work that out, we'll get approximately 16.3 degrees. Okay, so now the last one here, solve the right triangle. Round decimal answers to the nearest tenth. So on this one here, we have x, y, and z. And now again, notice how they have opposite the angle y, they have y. Opposite the angle x, they have x. So all of that kind of works out good. Okay. Sorry. So let's see, what would be the measure of angle y? Well, remember, x and y are going to be complementary because the other one's right angle, so those two add up to 90 degrees, because remember, a triangle equals 180 degrees, so then we can say that the measure of angle y is going to be 90 degrees minus the measure of angle x, which is 41 degrees. And if we work that out, we will get that measure of angle y is equal to 49 degrees. All right, so now, again, this is the one we know. So now let's kind of look at what we have here. So if I'm going to look at that, if I look at side x there, well, you can tell that one's the side opposite. And again, what is the other information that you know? You know that the hypotenuse is 18.4. So which one uses the opposite and the hypotenuse? You would tell me it would be sine. So the sine of x is equal to, again, the opposite over the hypotenuse, just to get you used to saying that. So then we can say that sine of 41 is equal to x over 18.4. Now on this one here, to get x by itself, I'm going to multiply both sides because I'm undoing the division. I'm going to multiply both sides by 18.4. So you can tell me that x is equal to 18.4 sine of 41 degrees. And if we work that out, and it says again to the nearest tenth, you should get approximately 12.1. Okay. And let's do our last one here. So our last one here, we're still using the one that we know. Well, we did x, so now we have to solve for y. So what is y? That's the one adjacent to it. So it's the adjacent and the hypotenuse, which uses adjacent and hypotenuse. Hopefully you've written it off to the side somewhere for yourself, but you know that that would equal, that would be the cosine. So you can then tell me that the cosine of x is again the adjacent over the hypotenuse. So we can say that the cosine of 41 degrees is equal to, our adjacent is y, over 18.4. Okay, so again, I'm going to multiply both sides by 18.4 since it was the one on the bottom. So if I do that, then I'll have y is equal to 18.4 cosine of 41 degrees, which would give us approximately 13.9. So that's that one. Forgot to say I was all done with the other one. And I'm all done. Those are the ones that you'll see. I'll give you a hint on the word problem. Thank you, people.